This is the most complex molecule. It's the one that's hardest to understand from a drawing on the board. Because we not only have bonds in the middle, top and bottom, we've got bonds sticking out away from the board and behind it. Okay? So what's happening here is we have one p orbital that's not hybridized. We have a second p orbital, the Pz I've got here in blue, is not hybridized. And both the Py is going to form a pi bond, and the Pz is forming a pi bond across the front and back. In addition to that, we have a hybridized sp orbital here that is overlapping directly on the line between the two nuclei. So it's forming a single bond directly in the middle, a pi bond top and bottom, a pi bond front and back. And then we're going to have either a bond or a lone pair sticking out both ends. So this is an ethyne molecule, commonly called acetylene. Sometimes it's called ethylene. Okay. For some of you, anybody do welding here? No. If you ever do any welding, you know what acetylene is. Okay. So here's the sigma bond directly on the line between the two nuclei, forming from the two sp hybrids, making a single bond in between, or one bond rather in between, called a sigma bond. Okay. Here is the pi bond going across the top here. Okay. And the pi bond going front and back here. Alright? So what we have is a pi bond going this way and a pi bond going this way. Does that make sense? And that's all around this sigma bond in the middle. In addition to that, we've got sigma bonds going out to hydrogens on both ends. Okay? Alright.
So the black ones bonded too?
Yeah, these are sigma bonds coming out to hydrogens. See where the hydrogens are here on the end? So this carbon has 4 electrons. It needs 4 bonds to finish its valence level. So I've got 3 bonds in between the 2 carbons, 1 sigma and 2 pi. So I need 1 more bond out here on each carbon to fill it out. Okay? Now this is a nitrogen molecule, and nitrogen came to the molecule with 5 valence electrons. So it only needs 3 bonds total. So when it does a triple bond, it's done. Okay? So there's the central sigma bond coming from the hybrid sp orbitals here. Here's a pi bond on top and bottom coming from the unhybridized p orbital. And there's a pi bond here in blue going front and back on both sides coming from this unhybridized p orbital, the blue one here. Now, some tips on making these models. Keep your color coding consistent, because you're going to have to explain all this. It'll make it easier for you to explain if your color coding is consistent like the drawings I made here. Just like yesterday. Try to make your color coding consistent. Lone pairs should be made of the round balloons. That's why you need round balloons today. Okay? So any place you have lone pairs, they're made with round balloons. But just a caution, don't make them really big. If you make them really big, it starts to make everything kind of look, unwieldy. Alright? Sigma and pi bonds should be made of your long balloons. But this is really critical. If you have a bond, like this one right here, it has to be tied on both ends. So I've got to be able to tie this end of the balloon to these things, and this end of the balloon to these things. If you need to tie on both ends, can I borrow somebody's long balloon? Anybody's? Somebody long balloon? Here we go. I would suggest you find somebody else who has the really long ones like these, okay? Hold on to that. Those would be great for the short bonds going out to the hydrogens, but not to the big ones, okay? If you've got to tie it to both ends, when you tie the knot on this end, it's pretty easy to tie something to it. But this end, if you don't leave something on the end, you don't be able to tie anything. So before you start, you need to be able to tie it on both ends. You've got to plan ahead. Leave yourself about 1 inch, knot it off like that. Does that make sense? So you can actually do that. When you're making pi bonds, you can use the same balloon for both the top and bottom part. You blow this up into a pi bond, knot it here, blow that up, and knot it again. Does that make sense? Particularly the captains, Shane, Reese? Todd, that make sense? Okay. Recommendation. There are meter stakes back there under otter. I would recommend that your sigma bonds be about 20 centimeters. It's about this long. Longer than that, things start to get kind of unwieldy. Okay? Your pi bonds need to be longer than that so they can fit around it. Okay? So the part that goes around, you want to make those about 35 centimeters. Okay? So if you make this one 20 and the pi bond 35 and the other part of the pi bond 35, it'll work out pretty well for you. Okay? Try to get, when you knot everything up, get them knotted up really tight on the ends, okay? Any questions about any of this? All right. If you have trouble, your team captain is supposed to be the one that helps you get out of trouble. So if they need to come to me, usually the captain is the one that brings that information to me, okay? No horseplay. I know that's going to be really hard to do when we're playing with balloons, right? Okay. Yes, Todd?
Everybody has to do it.
No, your team has to do just your set.
I know.
But everybody has to do this one, yes. Every team has to have one of these. Because your job when you're finished is not just to make balloon models, but to come here and explain to the whole class how this whole process works. Okay? All the hybridization and bonding when you're done. So when you come here to explain, you want to, your team captain should get everybody in order so you can say, okay, this is our unhybridized molecule or atom. This is how it becomes hybridized. This is where those orbitals go when they come together. This is the p orbitals that stretch across. This is how they form those molecules. Got it? Ready to get started? All right, let's go.